right? We can also do some optimization. I will use the window. Let's say that I have river, and I don't know how to change this, the color of this. I have a river. No. Bath. Fill. Right, fill. Okay, I have it here. And I have a piece of land. And I have 2,400 meters of fence. So I know that the total length that I have is 2,400. Okay? And then I know that this is meters. I have to leave a space here. And I would like to have a square fence, any size that I want, as long as I have used my 2,400 meters. Of course, you recognize this is a typical example of optimization from a calculus course, right? So you can do the optimization that way. We're going to do it a different way. We know that this has a base as a text, so it's height. I know this height is here, and I know that I have a base. Oh. Okay, so I know that my area will be base times height, and my restriction will be that base plus 2 times the height should be equal to the total length that I have, right? So the first method that I will use, I will create a parametric table. I would like to have a visual input of what are my chances. Okay, so I will create a table. If I try to solve it, I check here and said you have 3 equations and 4 variables, so you cannot solve this problem, right? It's underdefined. So I will create a table, and I will say I will plot age and area. I forgot to put the area, so I will insert variables, area. Okay. And I will use, I don't know, the height of my land. So I will do it from 100 meters to, let's say, 2,300. Okay? If I have 100 meters height, will be it will be very wide. If I have 2,300 height, it will be very narrow. Now I just press F3 and I have the solution. Let me change it to cannot be longer than than 1,200, because then 2 times. So I will change this to 100, talking about committed mistakes. Okay, So if I press F3, I have it. But it's difficult to read those numbers sometimes. If you are more of a graphical point view guy, I will plot the area versus the area versus the height, and I will add some nice things like symbol, and I will have something like this. Okay, so I know that around here I will have my optimum. I know that it could be maybe 600. Okay? Or I can use an optimization routine that is inside the program. Min max. I would like to maximize area, and my independent variable, the variable that I will change, will be height. It will ask me to limit the space where I would like to look for. I will do the same thing. Was 100 and 1100, right? And I will start with a guess point, 101. Okay? And if I start, it solves and it tells me that the height is exactly 600, right? And the value, the maximum area that I can have is 720,000 square meters. The good thing is that if you look like that, you say, well, I don't see why this is important. I can do that with MATLAB. I can do that with a number of programs. The good thing that this has is that, remember that we saw the tables? And sometimes you need to interpolate. Remember when you need to interpolate between two numbers, or between a double interpolation, you need to perform 3 interpolations, where you have, as part of the program, you have the thermophysical properties of number of substances. You have real fluids like 134A here. And with that you can compute all the properties that we computed in the course: enthalpy, entropy, specific volume, right? Saturation. No, I don't know.
So we're going to learn it in program, but you're not going to use it for the exam?
Not for the exam, for the projects. I have not checked that. Let me tell you. Let me stop this. Oh no, we can put it there. The reason I don't like it with the exam is then you are evaluating how competent you are with the program and not with the concepts. I have to figure out. We can discuss that. I am open to discuss.
I think we should, because we're going to be able to use it in real life.
Yeah.
That's why. Because in some, like, I had another course.
Yeah.
And we used Excel for everything.
Yeah.
But not in the exams. So you have to do everything by hand.
Yeah. I understand.
It's smart, because if you learn it in Excel, then how are you going to do it by hand? You know? I can do it.
That's why we have the projects.
Okay.
In the projects you and the homeworks. The homeworks you're gonna use it heavily. Okay? But I am open to discussion.
Even if we use the program in the exam, we still have to develop the equations that we're gonna use.
Mm-hmm.
So if we don't understand the concept behind what we're doing with the program, we will not even be able to write the equations into the program.
Let's cross that bridge when we get there. Right? Okay. So you have real fluids, guys. You have ideal gases. For our psychometrics course, we have a mixture of air and water. We have ideal gas formulation from the NASA. We have brines, which is a combination, for instance, of water and salt. And incompressible, we don't have anything here. But you also have, you have math functions, some functions that, for instance, some programs like Excel, I think Excel doesn't have Bessel functions or Bessel functions. You have heat transfer correlations for boiling, condensation, compact heat exchangers, convection. So when you take your heat transfer course, you will be able to install this again. And some basic things for mechanical design, that moments of inertia and stress concentration for very basic geometries. Okay? For instance, for sections, you move it here, and you have like the basic sections. It's not intended for solid mechanics, so it's very limited there, but it has very good correlations for heat transfer, fluid flow, and thermodynamics. When you study heat transfer, you will see that you need to iterate a lot just to get the adimensional numbers. You have also your adimensional numbers here. Hold on. Yeah.
Can you interact with the diagrams, like making they have like